pairs. So a pair is a set of two, right? So a factor pair is a set of two numbers that multiply to get another number. So for example, 2 times 5 is 10. So 2 and 5 we would say are a factor pair of 10 because if we multiply them, they give us 10. So those 2 and 5 are considered a factor pair of the bigger multiple, of the bigger number, 10. Will?
I think me and Colin did this last year.
Colin and I
remember doing this.
Well, we'll see. You may have. What's another factor pair of 10? What's another factor pair of 10, Sam?
1 and 10.
1 and 10. Very good. 1 and 10 and 2 and 5. Those are the only factor pairs for 10. Colin?
Is this like great common factors?
We'll get to that eventually, but yes, not today. Oh, I don't need the E. Look at example 1. This is a little word problem. You don't need to write all of this. You could just say, marching band equals 30 members. How many rows could be arranged? This is an application. This is a way that we would use factor pairs to solve this problem. If a marching band has 30 members, how many ways could rows be arranged? If you had to put the marching band into equal rows, well, we could use factor pairs. Give me one arrangement, Dylan.
3 rows of 10.
Okay, 3 rows of 10. 3 rows of 10. Good. What's another way? Owen?
2 rows of 15.
Good. 2 of 15. What else? Hudson?
5 rows of 6.
Good. 5 rows of 6. What else?
6 rows of 5.
Good. 6 rows of 5. And vice versa. Now we can go back and do all of these. We could do 10 rows of 3. We could do 15 rows of 2. Right? We could also do 1 row of 30, right? A really long row, or 30 really short rows of 1. Okay, so there's a lot of different ways to do this. But all of the ways involve finding the factor pairs of the number 30. Modibo.
Can we do 5 rows here and 6 rows over here? 5 rows and 6 columns?
Yes, that's what it's saying. All right. So let's look at this. The hint. Oh, I should put the hint up first. Find the factor pairs of 30, but you guys figured that out even without the hint. So way to go. Okay. I'm going to do number 1 with you. I'm going to bump this back real fast just so that we can do number 1 together. List the factor pairs. The way that you may have seen this done in the past is with the rainbow. Have you seen the rainbow? I'm going to show you it. Okay.
What exactly?
It shows factor pairs so that you can not miss any. Okay. So for example, the first factor pair is always 1 and the number, right? Every number is divisible by 1 and itself. So what you do is you start with 1 and then we put 18 on the other end. Now you don't need to draw, but this is why it is called the rainbow, because you can sort of match the factor pairs. That's a factor pair. Okay, what's the next factor pair that we would do here? Liam?
3 times 6.
Smaller. What's next after 1? 2 and 2 and 9. Right? So you kind of work up through all the factor pairs. 2 and 9, then what? Then what's the next factor pair for 18? Miles?
6 and 3.
Good. I'm going to do it in order. 3 and 6. So do you see why it's called a rainbow?
Yeah.
Because it just matches up the factor pairs, and you just go in order, smallest to largest, until you run into a repeat. So 1 works, 2 works, 3 works. Does 4 go into 18? No. Does 5 go into 18?
No.
Does 6 go into 18?
Yes.
Yes, we already have it, meaning we're done. So these are all the factor pairs of 18, bless you. And that's using the rainbow method. I find it helpful because it makes sure that you don't miss anything. You just kind of go in order from the smallest to the greatest, and once you hit one that you've done before, you know you're done. Once you hit one that you've done before. Phones off, please. Try one on your own. Look at this one. Number 2, please find the factor pairs of 24. Try using this method. You don't need to draw the rainbow unless it helps you. But that helps you figure out.
That looks like a tunnel.
So your first factor pair. What'd you start with? Tate?
Well, besides 1 times
Yeah,
24,
let's do that first.
2 times 12.
2 times 12. Exactly. So our second factor pair, 2 and 12. What's our third, Kennedy?
3 and 8.
3 times 8 is also 24. Dylan?
4 and 6.
4 and 6. 5 doesn't go in. 6, we've done it already. We're done. Here's all of our factor pairs. Because we hit 6, we've already got that in there, so we're done. Does that make sense?
Yeah.
Okay, let's do one more.
Wow.
Find all the factor pairs of 51. I'm going to put this up here. I also have a poster. Knowing your divisibility rules, sorry I messed it up a couple times, but then it comes up right. Knowing your divisibility rules is very helpful in finding factor pairs. Okay? If a number is divisible by 2, it ends in an even number. So anytime a number ends in an even number, it's divisible by 2. Is 51 divisible by 2? No, so you won't be able to use that in your factor pair. Divisible by 3, this is an interesting rule. If you add the digits of the number, so for 51, we would add 5 plus 1, which equals
6.
if that number, that when you add the digits, if that's divisible by 3, the whole thing is divisible by 3. So is 51 divisible by 3? Colin?
Yes.
Yes. I asked Colin. Because why?
Because 51 divided by 3 is 17.
Yes, but according to our divisibility rules, 5 plus 1 is 6. 6 is divisible by 3, so 51 is divisible by 3. Okay? 51 looks like it might be prime, doesn't it?
Oh, yeah.
Like it looks like, oh, this doesn't have any other factor pairs besides 1 and 51, but actually it does. So knowing your divisibility rules will help you see, 5 plus 1 is 6. That's divisible by 3, so 51 is divisible by 3. And what did you say it was, Colin? Or did you have a question?
I have a question.
Go ahead.
It was 17.
Yes.
And then,
Oops.
isn't composite or prime that's under 2 digits or 2 or under?
Prime digits 2 and under. I don't know. That's a good question. I don't know. That's a good question. I would need to look that up before I answer it for certain. Okay, so 51 we said is divisible by 3. Okay, the divisibility rule for 4 is that the last 2 digits would be divisible by 4, so we'd actually have to check this. Is this divisible by 4? Did anyone try to do the math? No, 4 doesn't go in. 5, any number divisible by 5 must end in a 5 or a 0, so is this divisible by 5? No. Okay, divisible by 6, it has to be divisible by both 2 and 3. Well, it's not even, so it's not divisible by 2, so it's not divisible by 6. Okay, there's no rule for 7. You just have to check. Know your 7's times tables. 51 is not divisible by 7. Number 8, is it divisible by 8? No, and again, your times tables will help you with this. 51 is not divisible by 8. Okay, 9 is another one where you add the digits. So 5 plus 1 is 6. Is 6 divisible by 9? No. So 51 is not divisible by 9. And then 10, it has to end in a 0. So our factor pairs are just these. It doesn't have a ton. But going through your divisibility rules, make sure you don't miss anything. Okay? All right. Now let's talk about prime factors and then prime factorization. So prime factors are when a prime number makes up half the factor pair. So a prime number makes up half the pair. Remember that, what is a prime number? What's the definition of a prime number? Will?
It can only be multiplied by 1 in itself.
Yes. A prime number, I'm going to write this here just in case we don't have it. Oh, no. A prime number is only divisible by 1 and itself. Okay? So when we talk about prime factorization, we are always looking for prime numbers that make up the factor pair. So 2, 3, 5, 7. Those are prime numbers. 1 is not prime. We don't count that as a prime number. We do not use it in our factor trees. 2 is the smallest prime number. Because by definition, a prime number is only divisible by 1 and itself. 1 is itself, so you can't do 1 divided by itself when you've already used 1. So 1 is not prime. 2 is our smallest prime. Okay? So here's a list of some of the first few prime numbers, if that is helpful. 2, 3, 5, 7, 11, 13, 17, 19, 23. Those are some of the smaller prime numbers. These are the ones you're probably going to use the most. The other ones, you're getting into big numbers, and you probably won't use them as much, but you will use 2, 3, 5, 7 a lot. So be familiar with the small prime numbers that you can use as factor pairs as we figure out how to break down a bigger number. Okay? Okay. Now, prime factorization, which is what this lesson is all about. Prime factorization is where we write a number as the product of its prime factors. So we're looking for the prime numbers that go into a bigger number. And then we write it using exponents, which is why we started this chapter with exponents, in a particular way. And I'll show you how to do that. So writing a number is the product of its prime factors. So prime numbers are super important. Being familiar with them and being able to pull them out is really important. Now, this is where you'll say, oh, yes, I remember this, or I don't know what you're talking about. Use a factor tree to help find the prime factors. Have we done factor trees? Okay, good. Then we'll learn something new today. A factor tree is how we do prime factorization. So if you are ever asked to find the prime factors or give the prime factorization, you want to use a factor tree. Okay, that's what helps you figure this out, is a factor tree. So we're going to do this on our next slide. We'll do some practice using the factor tree. Remember your prime numbers. Those are going to be what helps us make the factor tree, is prime numbers, prime factors. Okay. You got 30 seconds. Practice finding the prime factorization. So here's what it says. It says write the prime factorization of 48. So that's our number. And we are going to take 48, make a factor tree, and then write prime factorization. So there's kind of two steps here. First, you have to make the factor tree, to find the prime factors. Then you have to write it in exponent form, in prime factorization form. So let's start with our factor tree. To make a factor tree, you start with your number at the top. So we put 48 at the top of the factor tree. It's like a little Christmas tree. Okay? And then you ask yourself, what are the prime factors? I'm going to start with 1. What is one prime factor? What's the first prime factor, the smallest prime factor you can think of that you can see goes into 48? Roger?
48 times 1.
Not 1 because it's not prime. What's the next? 2. 2 goes into 48. So put your 2 over on that side. And then what's the other part of the factor pair, Colin?
24.
2 and 24. Once you have a prime number, circle it. Because that part of your tree stops. Right? We can't go any smaller than 2 because it's prime. But 24, is that prime?
Yes. No.
24 is not prime. Is there a prime factor, Hudson, that goes into 24?
Well,
Is that prime? What's its counterpart?
3.
Yes. Okay. 3 goes into 24. Would you agree? Okay, so let's do that. 3 and what? 8. So oops, not 8. 8's not prime, so I'm not going to circle it. But 3 is prime. That part of my tree is done. I keep looking at 8. Mia, what's the prime factor of 8? 2. 2, and what's its counterpart? 4. Tate, what are we going to do for 4?
2.
2 times 2. And now, once we have all circles at the end, our factor tree is complete. We have found all the prime factors of 48. But our last step is to write it in proper form. So here's what we do. This is all multiplication. This is 2 times 3 times 2 times 2 times 2. It's all multiplication because these are factors. That means we're multiplying, right? So we're going to write this using exponents. Instead of saying 3's by itself, we don't have more than 1 3. So 3's all alone. But we have 1, 2, 3, 4 2's that we're multiplying. How would we write that, Kennedy? With a hand. Miles. 2 to the 4th power. Would you guys agree?
Yeah.
That instead of saying 2 times 2 times 2 times 2, we could write that as an exponent 2 to the 4th power. Because we're multiplying it 1, 2, 3, 4 times in our factor tree. Right? Yes.
Doesn't 6 and 8 go into 48 too?
Yes. Yep. Yes. So her question is, don't 6 and 8 go into 48?
Yeah.
Yes. You could do it that way. What you would do, let me just show you just in case you guys do it. This way, I'm going to do it the other way. If I did it this way, 48, and I start with 6 times 8. Should I circle either of those?
No.
No, because why? They're composite. They're not prime numbers. So I would keep going. What goes into 6? What prime factors go into 6? Hudson?
2.
And 3. Okay, so now my factor tree is done. What goes into 8? 2 and 4. I've got 1 that finished. And I've got 4 again goes down to 2 and 2. So look what I end up with. The same thing. 1, 2, 3, 4. 2 to the 4th times 3.
Will it always be the same thing?
As long as you do it right, it will always be the same thing.
So that's kind of a way to check it too.
Yeah, so you can always, as long as you are completely getting to the end of your factor tree, it doesn't matter how you start. I like to start with the prime factors. I like to be like, does 2 go in? And I just do 2, 2, 2 until I'm done with all the 2's, and then I look for 3's. The second part, you guys, is writing it like this with an exponent. So like, how many times did you have each prime factor repeated? Write it as an exponent, and we're always multiplying those factors. Okay? Let's do another one. Oh gosh. Hold on. Let me do a little erasing. Okay. I'm going to do a little erasing so we can do a little bit of try it.
This is upside down ice cream cone.
All right. Shh. I want you to practice 5, 6, and 7. You can spread these out in your notes. You don't have to do them all right next to each other, or you could, do them one at a time in a column. But please do the prime factorization of 20, of 88, and of 90. Start by finding the prime factors, make your factor tree, and your last step is to write it as multiplication with those exponents. With our prime factors, I would start with 2 and 10. Could you do 4 and 5?
Yeah.
Sure. If you do it right, you'll get the same answer. So 2 and 10, 2 is prime. I'm going to circle it because I'm done. And then 10, its two factors are 2 and 5. Those are both prime. So now my tree is done. My last step is to write this in exponent form. So 2 I have twice, so I would call that 2 to the second times 5. All right, let's look at 88. I would start with 2. Do you have to start with 2? No. I would start with 2 and 44. 8 and 11 would be fine. You'll see we'll get to the same thing. 2 times 44 is 88. 44 is not prime. It's still divisible by 2. 2 and 22. 22 is not prime. It is divisible by 2 and 11. Now I'm down to only prime factors. 2, 2, 2, and 11. So I have 3 2s. I'm going to call that 2 to the third times 11. Modibo. And then 45 is 5 times 9. 5 is prime. I'm getting really tiny down here. 9 is 3 times 3. Those are prime. So to write this, our last step, write it as prime factorization. 2 times 5 times what? 3 to the second power. Very good.